and stationary wave formation in sound or longitudinal wave is basically the discussion of today's topic. So जब हम लोग ये बात करते हैं कि stationary waves are formed in longitudinal waves, so longitudinal wave means simply those waves in which compressions and rarefactions are being produced, and those waves in which the particles vibrate parallel to the direction of propagation of the wave. So if I have the displacement and distance time graph at node, there is no displacement of the particle, but at anti-node the displacement is highest. That's why I will get this type of graph, and this graph is basically the graph which represents the displacement or amplitude of the wave with respect to their position. For example, if you now, okay, we were having this the same thing here. So this is what, this is basically the displacement, na? This is displacement of the particles from mean position. So if it is displacement of the particle from the mean position, we can simply say that the particles are having zero displacement here. इसको हम ग्राफ बना सकते हैं ना, from this point to this point. So particles have maximum displacement at the node, and as we move toward at antinode, and as we move towards node, the particle has displacement equal to zero. And same goes here in your stationary waves, stationary longitudinal waves, this way. Yes. So in longitudinal waves, the vibration is not perpendicular to the direction of sound wave. It is basically parallel. So here particles have no displacement at all. Here the displacement is little more than that. Then displacement increases, and at this point the displacement is highest. That means this is your antinode, right? This point is your antinode. Is this clear?
जी सर क्लियर
Okay, good. Okay. So right after that, this is the topic जिसमें हम लोगों ने ये करना कि how to determine the wavelength of the wave in stationary waves, or the stationary wave formation in a closed tube. This tube is basically having a mic. This is a mic. Okay. Then there is a speaker or a sort of oscilloscope. This is a source of wave, source of sound, and there is a scale attached with the tube. The mic has a fixed axis, यानी mic can be slided over the axis. आप इसको move कर सकते हो along the axis. So when we are going to move this mic, or when we are going to slide this mic along the axis of the tube, at some points you get nothing. The nodes are the point where you get the quiet point, and anti-node is the point where you will get the loudest sound at this buzzer. So when we will move this mic from this R to S, R mean you can say it is a reflecting point or reflection, and this is basically your source point. Yeah, source speaker कह सकते हो आप इसको. So actually what happens, a progressive wave is traveling from speaker to this reflection surface, and then a wave reflected back from there. These two waves overlap each other in the path, and due to this overlapping, at some points they cancel the effect of each other, and at some points they enhance the effect of each other at the antinodes. So in this way a stationary wave is formed. So हम लोग करेंगे क्या? The main objective or main procedure in this all situation is, this is the zeroth position of your mic, and this will always be a node. Remember this thing, that at your closed end there will always be a quiet point or a node, and when you will move the mic from quiet point to the towards speaker, you will get a louder point. Just mark the position there, or if you don't mind, mark this position, just mark the next quiet point. For example, next quiet point is at 40 centimeter mark. Then slide the mic towards source and mark the next quiet point. So let's say it is at 80 centimeter mark. So it is obvious the distance between two consecutive nodes is equals to 40 centimeter. Is this clear to you?
Yes, sir, clear.
Okay. So during this all, the length of one loop is half lambda by 2. So if lambda by 2 is equals to L, it means L is equals to L is sorry, if L is equals to lambda by 2, it means lambda is equals to 2L. Lambda is equals to 2L. So by using this equation, V is equals to FL, you can find that the speed of the stationary wave is equals to V is equals to 2FL. V is equals to 2FL. Is it clear to all?
Yes, sir, clear.
Okay. To produce a sound wave, stationary wave in the sound, this is the procedure what I have explained to you. Use a tube with a with a graduated with a graduation or the scales on it, a mic which moves along the axis of the tube connected with buzzer or CRO, the speaker, a speaker or a sound source connected with the frequency generator of the noun frequency. Yani the frequency would be known to you. Two progressive waves will overlap, moving in opposite direction. They will cause the formation of nodes and antinodes. So, yani, this is the all what I have told you. The nodes are the points, are quiet points of the are zero amplitude or zero loudness, and antinodes are the points of the highest loudness or the loudest point. So what is the procedure? There are two questions asked in this topic from you. How to calculate the wavelength of the progressive wave? How to calculate the wavelength of the progressive wave? So to calculate the wavelength of the progressive wave, measure the distance between two consecutive quiet points. You got this point? Measure the distance between two consecutive quiet points, and then after that, yani, measure the length between them and then multiply it by 2. That is equals to wavelength. Just go back to the points here. What did you do? You have measured the length between, that was 40 centimeter, and you multiplied that length by 2 and you got the wavelength. That is the point what I'm saying to you. Is it clear to you?
ठीक है सर, समझ आ गया.
दोबारा बताऊं?
हाँ सर, एक बार रिपीट कर दें.
मैं ये कह रहा हूं कि आपके पास क्या है, आपने वेवलेंथ कैलकुलेट करनी है ना प्रोग्रेसिव वेव की, तो आप दो कंसेक्यूटिव नोड्स या क्वाइट पॉइंट्स के बीच की लेंथ मेजर करो, ठीक है, और उसको किससे मल्टीप्लाई कर लो, 2 से मल्टीप्लाई कर लो, दैट इज इक्वल टू योर वेवलेंथ. वो कैसे? ये देखो, दैट इज द क्वाइट पॉइंट, दिस द क्वाइट पॉइंट, एंड यू हैव मेजर्ड द डिस्टेंस बिटवीन दीज टू क्वाइट पॉइंट्स. वो डिस्टेंस आपका अकॉर्डिंग टू दैट डायग्राम, what was that distance? That distance was equals to 40 centimeter. So what would be the wavelength? The wavelength would be equals to lambda will be equals to, ये equation है ना, देखो, L is equals to lambda by 2, so lambda is equals to 2L, so lambda will be equals to 2 times 40, so that is equals to 80 centimeter. Is this clear to you?
जी सर, क्लियर.
बेटा क्लियर है ये बात?
जी सर, समझ आ गया.
Okay, now to calculate the speed of sound, this is 3 marks question. Yani here I told you that this is 2 marks question just to calculate the wavelength, but when the question will be asked to you that calculate the speed of the wave, then you will be awarded 3 marks. Okay,
सही सर.
for
ठीक है सर.
okay, for this purpose you will do nothing. Simple, V is equals to F lambda use करना है. Use this V is equals to F lambda, where lambda is equals to 2L, where lambda is equals to 2L, we measured that, and then replace lambda by 2L, so your now equation will be V is equals to 2FL. Yani the new equation is V is equals to 2FL. The new equation is V is equals to 2FL. Is this clear to all?
2
Yes.
3%.
तो इसका मतलब ये हुआ कि when we are going to have this situation with us, that we have to calculate speed. So speed is equals to 2fl, or when we are going to calculate frequency, the frequency is equals to v divided by 2l. So this is the first situation, our first fundamental frequency of any stationary wave, which can be yani, that sorry, of any progressive wave, which could be calculated by your stationary wave formation method. Got it?
जी सर.
Okay. Just a second. Okay, so the observation of intensity of sound at buzzer mic. This is very, very, very important graph. That how do you observe the intensity of sound wave at the buzzer? Buzzer mean the output. That is when you observe the frequency or intensity of the sound wave at the buzzer at starting point. At a starting point, you will observe the highest point, let's say. Yani, this is that there are there are 2 points which I have to mention. That this is the reflected position. Maybe it was reflection one, and this is the zeroth position. Yani, this is, let's say, your source side. So at this is the open end. Yani, that's why I have written source, and here I have written reflector or reflected. So at source the intensity is highest. This is the node, this is antinode, this is node, this is antinode. So this is not a progressive wave. So when it is not a progressive wave, the problem is the distance between two antinodes. Distance between two antinodes. What is the distance between two antinodes? It is lambda by 2. What is that? It is lambda by 2. So according to that diagram what I have started, what was lambda by 2? Lambda by 2 was equals to 40. So it means the wavelength is equals to 80 centimeter. You got that point? देखो दोबारा बता रहा हूँ. Am I audible?
Yes, sir.
Yes sir, आवाज आ रही है.
Okay, so I'm saying that, for example, this is the source, the open end of the tube. Let's say this end of the tube here. Here you are getting an antinode. So when you are getting an antinode, at this point the amplitude would be highest, right? At quiet point, yani at 80 centimeter mark, the amplitude would be 0. Again, highest 0, highest, and so on. So this all travels in this way, and that is the graph which shows you the intensity with respect to the position. Intensity with respect to position. And if you have the amplitude square graph will be same as intensity graph. Please remember this concept, that this graph is not amplitude, this is your amplitude square graph. So if amplitude square means this is your antinode, this is your node, and so on. So this is your antinode, this is my node, this is antinode, this is node. So the distance between two consecutive nodes is a distance between these two peaks. That is not lambda, that is lambda by 2. Remember this. This is the trick which the students have confused in, that it is actually lambda by 2, because that is the distance between this is not the distance between two consecutive peaks. It is the distance between two antinodes. Got it?
Yes, sir.
Yes, sir. ठीक.
Is it clear to all?
Yes, sir.
Yes, sir.
So that is the stationary wave formation in enclosed ended pipe. That was that the stationary wave formation in a pipe. So there are two pipes, one that is closed and at one side and open end on the other. Okay,
Yes.
one end is open and one end is closed. So the closed end will always give you a node. Remember, these all are the actually, these are the points what you have to recall. But I told you the logic behind these points, that the node is at the point of reflection. You will get your wave would be basically have your amplitude would be cancelled out, your wave would be cancelled out, displacement will be zero. So here we go, that in this situation, in this situation, the node is observed as the closed end and an anti-node is observed at the open end. So this is the mathematics behind that also. Please take care of this. The distance between node and anti-node is lambda by 4. Did you notice that? This is a node, this is an anti-node. So distance between a node and an anti-node is lambda by 4. It means that if you get the basic stationary wave, yani one loudest sound, actually when you will get then an anti-node at this open end, that will be observed in the form of loudest sound. Okay, anti-node is this basically what? Anti-node is loudest sound, a louder bang when where antinode is there. So when the length of the tube is 2 centimeter, sorry 20 centimeter, here I have mentioned that if the length of the tube is 20 centimeter, in that 20 centimeter you have heard the first loudest bang, right? This is the first loudest bang. This is the second loudest bang, and yes, I have prepared just two diagrams here. So what happens? The first is observed at 20 centimeter length. What about the next? It is not possible to have a stationary wave when you have doubled the length. When you have doubled the length, 20 to 40 centimeter, the distance between, because you have not changed the wavelength of your wave, so this is mandatory that in 20 centimeter, one node and one antinode should be formed. So in next 20 centimeter, one node and one antinode will be formed, and so on. So later on, next, if you have increased the length three times of the original length, then you heard the second bang, second loudest sound. So this is very, very important thing, that if one pipe is open and one pipe is closed, the distance between yani the basic length or fundamental length required to form a stationary wave is lambda by 4, and the fundamental frequency of the stationary wave is v by 4l, v by 4l, v by 4l. Remember this thing. So the louder bangs, consecutive louder bangs are here, are at L, 3L, 5L, and 7L, and so on. So here is the formulation. In this formulation, I have just considered all the points here. Just if the first frequency is V by 4L, okay, then second frequency is V 3V by 4L, because the length is three times. Yani the second length at which you are increasing the length of the pipe, and the wave which is formed, yani, if you heard the loudest sound, that loudest sound is heard when you increase the length three times, not two times, not four times. Then you increases the length again, and the next sound is heard at 5L, next at 7L, and so on. So in this case, you have all the frequencies, yani odd number of frequencies, odd number of wavelengths, and odd number of lengths at which you are getting this all. So I can simply say that you can hear the loudest bang at uh, F1, yani here is that. F1 is V by 4L, F2 is 3 times F1, F3 is 5 times, and 7 times, and 8 times. So this is basically what this is 2n plus 1 formation. Fn is equals to 2n plus 1 formation. So if n is equals to 0, 1, 2, 3, 4, 5, 6. So at all odd multiples of lambda, multiples of lambda, at odd multiples of lambda, you are getting this frequency. Is this clear to you?
Yes.
Yes, sir, समझ आ गई.
Okay. So this is very, yani this question is frequently asked to you. So please remember this. The next is the stationary wave formation in a pipe with both ends open. With both ends open. If you have a pipe with both ends open like this, you will get two antinodes at the open ends. What will you get? Two antinodes at the open ends. Are you getting my point? And node will be formed in
Yes, sir.
between. Nodes will be formed in between. Actually, open ends means the waves are, the particles are allowed to vibrate easily, or to the maximum level. That is why you are getting the antinode. So when you are getting antinode, you can simply consider it that two uh, antinodes are formed at the open ends. Is this clear to all?
Yes.
Yes, okay.
Okay. Right after that, if you see that, okay, this is the diagram. I want to make this very clear to you that if we simply see this all situation, that uh, for yani this is a quarter lambda, sorry, half lambda. Did you see?
Yes.
So if it is a half lambda means that this is basically a sort of, for 1.1, from this point to this point it is lambda by 4, from this point to this point it is lambda by 4. And if you consider that there are two lambda by 4s in one pipe, two lambda by 4s in one pipe, so this is fundamental frequency, our first harmonic. And then you have this yani the science of this is that if you have considered the length as lambda by 2, because this is quarter lambda, lambda by 4 here, lambda by 4 here, and lambda by 4 here. So how much that is? That is total lambda by 2. So this length is equals to lambda by 2. It means it has the same science or same maths as f1 is equal to v by 2l. So this is the fundamental frequency. So first overtone or the second harmonic is obtained when you have doubled the length. Here you can double the length. So when you have increased the length two times, did you see? You got 4 lambdas. 4 lambdas mean two half lambdas, right? And one complete wavelength. So one complete wavelength means here lambda is equals to length, and you can say that V is equals to F lambda and F is equals to V by lambda. So simply speaking, you will say that second frequency or second harmonic is 2V by 2L, yani 2 times F1. So that is second harmonic. Then again, when you have increased the length for third, so it would be 3F1 and so on and so on and so on. So in this setup, yani when one pipe is when both the ends are open, just see this all. That's it. F1 is equals to V by 2L. Okay. And length one is the required length is half of the lambda, but in your one end open and one end closed, you are required quarter lambda, right? So here length 2 is 2 times L1. Just see that 2 times L1, but in that one it was 3 times L1. There L3 was 5 times L1, but here L3 is 3 times L1, and so on and so on and so on. So simply speaking, when two ends are open, yani both ends are open, you will get the yani wavelength of as you increase the length by yani by 1. When you increase the length by L, 2L, 3L, 4L, you will get it. And similarly for the frequency, it would be obtained at F2 is equals to 2 times F1, 3 times F1, and n times F1. It is not odd, it is for integral multiple of frequency and integral multiple of lambda. So this was all about your syllabus even. Right? This is all from my side. So Alhamdulillah, at your 8th January, your one round trip is completed, and now I will start that again. I mean, I will select some of the topics, and those topics would be uh, actually, those will be selected according to the revision plan. Got it?
Okay.
Okay, sir.
Yes. Mohsin, especially for you,